Viewers, once again, I'm pleased to welcome you, and I thank you as you join me in this video as we explain the concept of redshift. Now, what do we mean by redshift? The concept of redshift applies to the propagation of a wave. Whenever a wave is moving through space, an observer notices a remarkable change in the wavelength or frequency of that wave. As long as there is a relative motion, if there is a relative motion between the source of the wave and an observer, then the observer will notice a change in the wavelength or the frequency of that wave. Now, if the observer moves away, if the observer recedes from the source of the wave, the observer will notice an increase in the wavelength of that wave. And this corresponds to a decrease in the frequency of the wave. And a decrease in the frequency of the wave also corresponds to a decrease in the energy of the wave. On the other hand, if the observer is moving closer to the source of the sound of the wave, if the observer moves closer to the source of the wave, the observer will notice a decrease in wavelength or a corresponding increase in the frequency or the energy of that wave. Now, the concept of redshift applies to all forms of wave. However, it derives its name from the light wave or optical spectrum. As we know, the spectrum of light consists of 7 notable colors: the red color, the orange color, the yellow, the green, the blue, the indigo, and the violet. The red light is observed to have the highest wavelength. So if the wavelength of the light increases, it means that there is an observation of that wave stretching towards the red end of the spectrum. On the other hand, if the wavelength decreases, the light is observed to stretch towards the blue end of the spectrum. Similarly, the energy of the photon or the light wave appears to decrease whenever the frequency decreases, but it appears to increase whenever the frequency increases. Now, the concept of redshift applies to all forms of electromagnetic wave. It applies to radio, it applies to X-ray, it applies to gamma rays and other forms of electromagnetic waves. Now, there are 3 forms of redshift. The first one is what we call the Doppler shift, which arises from the Doppler effect. The Doppler effect is actually a change in the frequency or wavelength of a wave whenever there is a relative motion between an observer and the source of the wave. So the Doppler effect is a major cause of redshift. Other forms of redshift include the cosmological redshift and the gravitational redshift. Now, for the cosmological redshift, it is noticeable when 2 astronomical objects are receding or moving closer to each other, so that the electromagnetic wave emitted by either of the objects tends to increase in wavelength or frequency, depending on whether the relative motion is a receding type or the type that gets closer to each other. Now, for the gravitational redshift, this redshift occurs as a consequence of general relativity. There is a notable effect called the gravitational time dilation, which leads to a redshift whenever there is a movement either towards or away from a gravitational potential. Now, gravitational redshift is not noticeable in region where the gravitational field strength is small. However, it is much noticeable in a region where we have intense gravitational field, like towards a black hole, when a radiation in form of light is moving towards the event horizon of a black hole. Now, redshift can be quantified using the expression. We use the letter Z to denote a redshift, and it is defined in terms of wavelength as Z equals to the observed wavelength minus the emitted wavelength divided by the emitted wavelength. So, thank you for joining me in this session. Do have a wonderful day.